On a previous example, we've showed you how to check a system solution of the system and to graph it. This example is asking you to use a graphing calculator, so go ahead and take out your graphing calculator. And we're going to, in class, run through these steps of how to graph a equation. So right now, if you know how to use it, go ahead and follow along. So we need to convert both of these equations to slope-intercept form. So I'm going to go ahead and subtract x from both sides. And then I'm going to divide both sides by -1. So the equation in the top in slope-intercept form is a positive x, because a negative divided negative is a positive, and then -2. So when we enter it into the calculator, we will run through these steps. All right, this equation here also has to be converted to slope-intercept form. So we need to add 3x to both sides. And then we have to divide both sides by 2. So in slope-intercept form, it's positive 3 over 2 x minus 1/2. And again, you would substitute the equation into the graphing calculator using those steps. What will come up are two lines, and they intersect at a point. There is a table function with the graphing calculator that looks like this. And it lists out, the first column is the domain, the x values. And then this is the range of the first equation. So right here, first equation. And then this is the range of the second equation. And what we're looking for is, where do the ranges match up? Where are they the same? So if we look right here at -5 and -5, their y values are the same, and the x is -3. So that's telling us where they intersect. So that ordered pair is -3, -5, which will be the solution to that system. The next thing is about classifying systems. So not every system is going to intersect at a nice point. So the first diagram shows the 2 points intersect. The next one shows that the 2 lines intersect at one line. That means that they are the same line. And then the last one is showing you 2 parallel lines. So here's how we classify these systems. If it's exactly 1 point, we call this consistent and independent. If the 2 lines are the same, they are considered infinitely many solutions, and we call this consistent dependent. They're coinciding lines. The last one is no solution, because the 2 lines do not intersect. They're parallel lines. They are considered inconsistent. They're parallel lines. So example 5 says, classify and determine the number of solutions for each system, and then use your graphing calculator to graph and look at a table. So to be able to use the graphing calculator, just like on a previous example, we need to get them into slope-intercept form. So if we take this top equation, x minus y equals 2, we need to get it into slope-intercept form. So we're going to subtract x from both sides, and then divide both sides by -1. And then simplify. So we get positive x minus 2. And we'll call this y1 in the graphing calculator. The second equation in the system, you again need to convert it to slope-intercept form to be able to use the graphing calculator. So we subtract, actually add 3x to both sides. And then we divide both sides by 2. And then convert to slope-intercept form. So you put the m first, and then the b. And we'll call this y sub 2. So then what you would do is you would graph the two equations, and then you'd look at the table in the graphing calculator. And what the table is going to show you, it's going to intersect at the solution point of -3, -5. So how we classify this, back up here, since these two lines intersect, they are considered consistent and independent. They have one solution. Consistent, independent, which means they have one solution. All right, another example here. Same thing. We would take and change that equation to slope-intercept form. So I'm going to go ahead and just do that. So y equals -4x plus 1. And then this equation here in slope-intercept form is y equals -4x minus 1. You would, again, type them into the graphing calculator. And what's going to happen is these two lines are parallel. They're not going to intersect each other. And you'll notice right here, this is a slope of -4 and a slope of -4. The two slopes equal each other. So when we look up at our table here, when the two lines do not intersect, they're parallel, they're considered no solution, and how we classify it as inconsistent.